Hello everyone. Welcome to the solution of LeetCode problem 685 named Redundant Connection 2. This problem is the follow-up question of redundant connection problem of LeetCode, and if you don't know about the redundant connection problem, I will suggest you to solve those problems first. After that, you can come back to this problem. Now here, in this problem, a rooted tree is a directed graph such that there is exactly one node, the root, for which all other nodes are descendant to this node. Plus, every node has exactly one parent, except for the root node, which has no parent. Now, the given input is a directed graph that starts as a root tree with n nodes with distinct value from 1 to n, with one additional directed edge added. The added edge has two different vertices chosen from 1 to n and was not an edge that already existed. Now, the resulting graph is given as a two-dimensional array of edges. Each element of edge is a pair of u and v that represents a directed edge connecting node u and v, where u is the parent of child v. Now we have to return an edge that can be removed so that the resulting graph is a rooted tree of n nodes. And if there are multiple answers, we can return the answer that occurs last in the given two-dimensional array. Now here, we can see that in this graph, 1, 3, and 1, 2, and 2 and 3 are connected. So the tree structure is removed and it's become a graph. Now, if we remove the edge 2 and 3, the graph will become the tree. So the desired output is 2 and 3. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, this is the follow-up question of redundant connection problem. In the redundant connection, we are using the disjoint set union data structure, and if we connect a edge, the highest possibility is that there forms a cycle. Or we can say that if both of the node has the same parent, then this cannot become a tree. Hence, we have to remove this edge. But in this problem, as this is a directed graph problem, so if we add a particular node or particular edge into the directed graph, there can be three scenarios. One is that a node can have two parents, or there exists a cycle, or there exists both, which is two parent with cycle. Now, let's examine the problem one by one. First, two parent issues. Suppose this is a tree. Now, suppose this node 4, 3, 2, and 1. Okay. Now, suppose there is an extra connection between 2 and 4. Now, the node 4 has two parents. One is 3, another is 2. In this case, if we remove this edge, the graph will become tree. So, this is the first scenario. The second scenario will be there can be a cycle. That means suppose it is the graph, suppose it is the tree, and the extra edge is this, which is 3 to 1. Now, in this scenario, if we remove this edge, then the graph will become tree. Hence, the second case will be resolved. So, another case will be two parent with cycle. So how can we solve these issues? Suppose this is the cycle and this node has two parent. Suppose it is 1, 2, 3 and 4. Now node 3 has two parents. One is 1 and another is 4. So here, if we remove this edge between 1 and 3, the graph will become tree. So, in short, for the two parent issues, we can easily detect the extra edge. For any node which has two parent, we can remove any of its connection with parents. Hence, the problem will be solved. And if there exists a cycle, we can remove any of the cycle edge. And if there exists cycle with two parents, then we can remove the edge which is presented in the cycle. And by doing so, we can use the union by size and the path compression, which is explained detail in the redundant connection problem. I hope you understood the algorithm. Now let's move on to the code. Here, to solve this problem, we have taken two vectors. One is parent, another is size. Now, for each of the parent, each node currently parent of itself. So parent of I will be I, and the size of each node is 1. Now, this is the find parent function. It is a recursive function basically. And here we are using recursion to find the parent of a node. And if the node is equal to the parent of node, we are returning the node. Otherwise, parent of node is equal to recursively calling the find parent function of parent of node. Now, it is a union by size, and we are calculating the ultimate parent of the node u and v. And if both of them are equal, we have to return false, because in this case, we have found a cycle. Otherwise, the size of the ultimate parent of u is less than size of ultimate parent of v. In this case, we have to add the ultimate parent of u to ultimate parent of v, which is added, and the size of the ultimate parent of v will be increased by the size of the ultimate parent of u. Otherwise, we will do the opposite. And if we able to perform union by size, we have to return true. Now here, in the main function, we are given the list of edges, and we are calculating the size of the edges and the parent initialized with 0. Now we are taking three vector, first edge, second edge, and the cycle edge. Now here, for each of the edges, if the current node has parent of 0, in this case, parent of v will be initialized with u. Otherwise, if it has already a parent, that means the current edge is the second edge. So the first edge will be the parent of v and v, and second edge will be the u and v. Now currently we are temporarily disabling this edge. That means edge of I is equal to 0. Sorry, edge of 1 is equal to 0. Now we are detecting the cycle here. For each of the edges, if we did not able to perform union by size, that means current edge will be the cycle edge. Now, if we have found the first and second edge, that means our first and second parent is already exist, and also we have found a cycle. So here we have to remove the first edge. Otherwise, we have to remove the second edge. Now, if this condition does not exist, then we have to simply return or remove the cycle edge. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.